So, you come into math class one day and you're feeling pretty good about yourself when all of a sudden your teacher starts talking about sin cos tan. And you're like, what the heck is this? So, let's take a look at what it is. So, they're basically ratios or fractions. So, let me break that down. If I know the angle in a triangle, sine, cosine, and tangent tell me how the sides of the triangle are related, right? So, imagine you have a triangle and one of the angles is really small. That's going to make the triangle look different than if that angle was bigger, right? So sine, cosine, and tangent are a way to understand how the angle and the sides of the triangle are related to one another. Okay, so I'm going to show you a quick visualization that is going to help you see what I mean. So let's see. We have this triangle here. I'm going to hide that for a second. So this is our angle, right? 39.8. This is the one that we're looking at. So I want you to look at a few things. I have this here, I equals 6.1. That means that this side is 6.1. And this side is F, so that's 7.3. So take a look at something. What's happening to those sides as I make the angle bigger or smaller? Interesting. So I'm making the angle bigger. I is changing, but F isn't changing. Okay, interesting. So the angle's getting as the angle gets bigger, I gets bigger. As the angle gets smaller, I get smaller. Okay. So next I want to look at this number. So that number is telling us what happens when I divide this number by this number. So right now if I divide 6.7 by 7.3, it's going to give me 0.9. So now let's do the same thing. Notice what's happening as I change the angle. What's happening with this number? Interesting. So as I make the angle bigger, the number gets bigger. As I make it smaller, the number gets smaller. So this number is exactly what a trigonometric ratio is. It's telling us the relationship between this side and this side. So this relationship, so when I divide this side by this side, that's going to be the tangent. And we're going to look at it a little bit more later. But it's telling you that as the angle gets smaller, the tangent gets smaller, and as the angle gets bigger, the tangent gets bigger. Okay, so next up, I want to see, why does this matter? Okay, so imagine one day you're walking in the city and you see a really tall building and you're talking to your friend and you're like, whoa, I wonder how tall that building is. Well, if you know trigonometry, you could actually find it pretty easily. All you need to know is how far away from the building you are and what angle you have to tilt your head up to see the top of it. So just with that information, you'd be able to give a pretty good answer for how tall the building is. So before we go any further, I want to review so we're all on the same page. So every side on a triangle like this, on a right triangle, has a name. So this side is going to have a name, this side is going to have a name, a special name. And I'll show you in a second. So first side that we're going to talk about is the hypotenuse. So if we go back to this little box that they gave us and we draw an arrow, it's going to point to the hypotenuse. So the side that the arrow is pointing at is going to be the longest side on the triangle, and that's called the hypotenuse. So side AB is the hypotenuse. The next side that we want to look at is called the opposite. So usually they're going to give us an angle like this. And what you can do is imagine you throw a rock in a pond and you throw it here at B. The first wave is going to spread out like this, then it's going to spread out like this, then it's going to spread out like this. And you want to know, where is it finally going to end up? Where's my wave going to end up? So you could draw the wave and you'll see that it's going to finally end up splashing on AC. So that's going to be the opposite. So we know we draw the arrow here, that's the hypotenuse. The wave spreads out and hits AC. And the last side is called the adjacent. So take a moment to practice labeling this one, and I'll show you the answer in a second. Okay, so we draw our arrow. This is the hypotenuse, it's the longest side. The opposite is going to be where the waves spread out and finally hit, and the adjacent is the missing one. So let's go back to trigonometry. When they're talking about trigonometry, they're usually going to write it out like this. So they're either going to say sine, cosine, or tangent. And these are the three that you can use. So let's break this down. This means sine of x, so sine of the angle, is equal to the opposite over the hypotenuse. That just means that whatever you put in for the angle, it's going to tell you the relationship between the opposite and the hypotenuse, and that's for sine. And for cosine, whatever angle you put in here, it's going to tell you how the adjacent and the hypotenuse are related, and the same for tangent. So let's go back to the example of the building, right? We want to solve this, so we're going to see how we can do it. So the cool thing with trigonometry, or the thing to remember, is we want to see all the information that we have, right? So here we know we have 30 degrees here. We don't know what the opposite is, right? That's h, but we do know what the adjacent is. So we have the angle and we have the adjacent. And we're only missing one piece of information, right? Which is the opposite. So looking at this, which of these could we use? In which of these do we only have one thing that's missing? So let's take a look. For sine of x, well, we have the angle. We don't know the opposite. We don't know the hypotenuse either. So we're missing two pieces of information. Okay, so we can't use that one. For the cosine, we know the angle. We know the adjacent, and we could find the hypotenuse, right? Because we have two pieces of information we could solve for the last one, but we don't really want to find the hypotenuse. We want to find the opposite. Okay, so we can't use cosine because that would only give us what this one is. So if we look at tangent, okay, we have the angle. We know the angle. We were looking for the opposite, so that's good. And we have the adjacent. Okay, perfect. So if I use tangent, I could plug in everything that I have and then solve for the opposite. So this is how we can set it up. We say the tangent of the angle is equal to the length of the opposite over the length of the adjacent. And what you can do is you can write the angle that you're looking for and then press the tan button on your calculator. So we can say tan of 30, and you can just put that in your calculator like that, equals length of O over 5,000. And then tan of 30 is going to give us 0.577. We keep solving, so we're looking for O. So our next step is we multiply both sides by 5,000, and we have O, 2,885 meters. So this is actually the tallest building in the world, I think by a whole lot. This is kind of like as tall as some mountains are. So you found a really tall building. So go ahead and take some time to practice this one and pause the video, and we'll come back to it in a second. Okay, so the first thing that we wanted to do is label the sides. So we know we draw the arrow here. This is the hypotenuse. The wave spread out hit the opposite, and we don't know the adjacent. So, okay, we know the angle, we know the opposite, and we're looking for the adjacent, right? We're looking for this one. So once again, the one that we can use is tangent, because that's going to tell us the adjacent if we have the opposite and the angle. So then we use our calculator, we plug in 0.35 degrees, and we solve for A, and that's going to tell us 24.28. So that's what AB is going to be. So just to review a little bit, okay. Sine, cosine, and tangent tell you how the sides of a triangle are related based on the angle. So as the angle changes, the relationship between the sides is changing. The next thing is that there's three of them, and each one of them measures the relationship between different sides. The last thing to remember is that you want to see what are you looking for? Which one are you looking for? So if you're looking to find the hypotenuse and you have information about the opposite, so you probably wouldn't use the you want to find the opposite and you have the hypotenuse, you probably want to use sine. So it's kind of like a puzzle. Like they give you usually two pieces of information and you're looking for the last one. So see which one would be best and then use the trigonometric ratio that's best for that. Okay, I hope you enjoyed the video, and I'll see you next time.